Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's very hard puzzle, and it's called Fluffy by Mad Tyus. And here are the rules. We have normal Sudoku rules, where we need to fill every row, column, and marked 3 by 3 box with the digits 1 through 9. We also have three-headed beasts, where the grid contains 18 triple-headed beasts. I don't know why I said three-headed beast. Triple-headed beast cells divided into two separate sets of 9 cells each. Cells from the same set may not repeat in a row, column, or marked 3 by 3 box, and both sets have to contain the digits 1 through 9 once each. So think of them as there's triple-headed beast 1, set 1, and triple-headed beast set 2. There has to be one cell from triple-headed beast set 1 in every row, column, and 3 by 3 box, and there has to be one cell from every row from triple-headed beast set 2 in every row, column, and 3 by 3 box. And they must contain the digits 1 through 9 in triple-headed set 1 and triple-headed beast set 2 each. Cells from the same set may not repeat in a row. Oh yeah, I already said that. Within a marked 3 by 3 box, the two triple-headed beast cells, one of each set, may not appear in the same row or column. Okay. So basically, in a box, a 3 by 3 box, excuse me, you cannot have the triple-headed beast set 1 cell. So let's make it red and blue, I guess. You cannot have the triple-headed set 1 cell be in the same row or column as the same triple-headed beast set 2 if they're in the same box. And the value of a triple-headed beast cell from one set is the sum of the digits in the 3 triple-headed beast cells from the other set sharing its row, column, or marked 3 by 3 box. So that means, say we had triple-headed set 2 in these cells, and say this was, I don't know, it could be 9, 9, and 9. The value of this triple-headed beast cell is the values of is the digits. It's the sum of the digits of the other set's triple-headed beasts that are in the same box, that are in the same row, and that are in the same column. So the value of this cell would then be 27 in this example. So those are examples of triple-headed beasts and how you calculate the value. For all other cells, the value matches the digit in a cell. So in a normal cell, it's basically the digit. We have lines of silence. Interesting. So along red lines, the values in adjacent cells have to differ by 9 or more. And they're called lines of silence because there's no whispering, right? There's no normal cell. There's no two digits normally that have a difference of 9 or more, right? The greatest difference you have is 1 and 9, which is 8. So these are essentially whisper 9 lines. So along red lines, adjacent cells have to values have to differ by 9 or more. We also have thermos, where along thermometers, values have to strictly increase from the bulb to the tip. And the bulbs in row 3, column 3, and row 5, column 5, share a tip. So, for example, you could have a value of, say, 3, 7, and 8, and that would be valid. But what you could not have is, say, like 3, 8, 8, because the values have to strictly increase along a thermometer. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. On a line of silence, again, every two cells, in every two cells, there must be a difference of at least 9, which means one of the two cells has to be a triple-headed beast cell. So you can't have more than 2 in a box. So these are not triple-headed beasts. One of these, so we're going to make this red and this blue. In this set, there's one of 2. So this is the red set, and this is one of these cells. One of these is triple-headed beasts. So that means we have triple-headed beasts already for set 1 and 2 in row 1 and column 1. So these cannot be triple-headed beasts. We have one set here. We have another set here. None set here. Another set here. So same here. This has to be triple set. We don't know which ones these are, though. So these cannot have others. So this must be orange, and this must be yellow. That means there's no more in row 9 and column 9. That means orange has to be one of these two. Yellow has to be one of these two. Huh. You could have 2 triple-headed beasts, though, on the same... You have a minimum of... So, on this line of silence, or the Whisper 9 lines, you have to have at least 1 triple-headed beast. You could have 2, but with each other. This is not a triple-headed beast. This one is either 2 here. So this is either 1, 2, 3 as triple-headed beasts, or 1, 2. Can you have 1, 2, 3 is the question. So then this would not be triple-headed beast. This would be normal. This would not be triple-headed beast. This would be normal. I guess it's possible, right? Same with these. Yeah, it's possible. Or it's these two, which are triple-headed beasts. Hmm. Okay. At least one of these is triple-headed beast. It could be both. So either both of these are triple-headed beasts, or this and this and this and this are triple-headed beasts. So that means all of these cells see both of these, and these two cells see both of these. These two cells see both of these, so none of these can be triple-headed beasts, period. um... Hmm. So this, if it's here and here, okay. So say it was this and this. That means this could not be a triple-headed beast. This could not be triple-headed beast. So we would know this would have to be the red one, and this would be blue. So then this would be red. Ah, and we have a contradiction. So it cannot be that it's triple-headed beast blank, triple-headed beast blank, triple-headed beast. It has to be triple-headed beast here and here. Because if we try triple-headed beast here, triple-headed beast here, triple-headed beast here, these would be the same set, which is not allowed. So that means these two are triple-headed beasts, which means these cannot be. So these are not triple-headed beasts, which means one of these is, one of these is. These could actually still be triple-headed beasts, but we don't know. These two definitely have to be, though. Because, again, every set of two, you have to have at least one triple-headed beast. But we don't know which colors these are. These are opposite sets, though. So let's do green and pink, I guess. That's interesting. So if there's an orange here, that means this is green. This is yellow. So that would be orange, which means that could match that yellow. Hmm. How many can we actually fit, though? Because the triple-headed beast has to add up to at least 10 in the spaces that they are in. This has to be a triple-headed beast. Because if it's not a triple-headed beast here, and this is just a normal digit, you can't... So this is guaranteed to be triple-headed beast, which means this cannot be red. This is blue and triple-headed beast. It has to be the triple-headed beast here. Because if it's not, this can't be just single digit and single digit, because this is greater than this one. Same with this. So this cannot be orange. This is yellow. So this is blue, which means we have triple-headed beasts in set 1 and set 2 in rows 1 and 2. Red is one of those two. Blue is one of those three. Triple-headed beasts can be from 3 to 27 in value. Okay. This is yellow, so this can't be triple-headed beast, and this can't be triple-headed beast. Orange is one of those two. So this has the same reasoning, right? Huh. This strictly increase from the bulb to the tip. Share a tip. Hmm. Okay. What else do we have? So we know these values just have to be greater than, have to be 10 or greater. These values have to be 10 or greater. Uh, hmm. This is a normal digit. This could be a triple-headed beast if it's small enough. It could be like 111 adding up to a value of 3. Um, huh. Hmm. Huh. Oh, triple-headed beasts cannot be in the same, if they're in the same box, they can't be in the same row or column. So this cannot be triple-headed beast here. This is then the orange, and it cannot be blue. So this is red. So yellow has to be blue, and orange has to be red. Okay, so yellow's one of the yellow is blue? Yeah. Um so this can't be yellow, that has to be red. Okay. Hmm. That means we have all the triple-headed beasts for column 2 and column 8. We have a red here somewhere, a red here somewhere. Blue. Okay, so one of these is a blue. The other one has to be one of these two. Same with this. One of these is a red. Okay. Hmm. Can this ever be... So this could only be red, if possible. That would mean red would be here. This couldn't be blue, so blue would have to be here. So if this is red, this would be red. This would be blue. This couldn't be the same. So this would be blue. This would be red. This would be blue, and this would have to be blue here. So then red would have to be here, if that's the case. Red would be here, so this couldn't be red here, so this would be red here, so this couldn't be red here. So this would be red here. Blue could not be here, blue could not be here. And you could have some sort of blue pair here. These would all be done. Okay. What happens if red is here? If red is here, this is blue. This is red, obviously. This can't be blue anymore, so this can't be blue. Okay, and then red would have to be here. So red could not be here, which means red is here, which means this can't be red, so this would be red here. Blue can't be here. Blue would be one of those two. Blue would be one of those two. And that's fine. If red is here, then that means this is blue, which means this can't be blue. This is blue here, which means this can't be blue. This is not green. This is red, which eliminates red here, which means this is not red, so that's red. Blue would be one of those two. Blue would be one of these two. Okay. So, unfortunately, all three of these seem like they could be the case. We're gonna have to start putting some digits in. Uh, uh, hmm. Um, so this must be at least 10. This must be at least 10. These are the interesting ones, right? We don't know, like, so both of these are two-headed beasts, or triple-headed beasts. These have to be greater than 10. These must be greater than 10. Huh. Yeah, I'm not sure how to tackle the numbers. Do we have anything else? 1 through 9 may not appear in the same row or column. Yeah, it's not very restrictive, so it's going to be kind of problematic trying to figure out where everything is. Hmm. Oh, actually, that is interesting. Hold up. Okay. Let's look at the different possibilities for red here or blue. Let's just do red here. If this is red, that means this is blue and this is red. So obviously this can't be red, which makes that red. So this can't be red here, so that's red. Blue's here, so this can't be blue. Blue's here, so this can't be blue. So then red would have to be here. Blue is one of those two. It cannot be here because that would... Okay. So then blue would have to be here and blue would have to be here. That's interesting. Okay, so then one of these would have to be next to a low digit, if that's the case. Oh. Oh, wait, no, this is thermometer. Okay. That's interesting. So that's if that's... Okay, so if that's red... If this is red, then this can't be blue. Which means this can't be blue, this is red. Which means this can't be... This is blue, so this can't be blue here. Red eliminates red here, so this is red, which means that can't be red here. Which means this is red here. Red has to be this cell. Blue cannot be here because that would be the same column in the same box. So this would be blue and this would be blue. Okay, so then you'd have... Okay, so the one thing that's interesting, this would be blue, blank, and red. These would have to be both red, and this would be blue and blue. That's interesting. This would have to have a value of like over 10 then. Okay. What happens if it's here? So if this is red, then this is blue, which means this can't be blue. This can't be blue. This is red, so this can't be red, which means that can't be red here. Red would have to be... Oh, not possible. Okay. So if this is red, that forces this to be blue, which means this can't be blue. That's blue there, which means this can't be blue. So then this, you'd have blue and red, blue and red. But that's not possible because then this, in this box, you'd have a red and a blue in the same row. So you cannot have red here. So the choices again. Let's just go through the choices. If this is red here, that means this is blue, this is red. So this cannot be blue here, this must be blue here. That leaves that as blue. This is red, so this can't be red, therefore that's red, which makes that red. Blue cannot be in the same column, in the same box, so blue would have to be here. Red would have to be here, and blue would have to be here. So that's one possibility. The other one is if this is red, this can't be blue, so this must be blue, which forces this to be red, which forces this to be blue. So this couldn't be blue anymore, which means this is blue. So again, red here, red, blue. This would be blue and blue there. So red and red. If this is red, this can't be blue, so that's blue, which makes that red. So red and red. Blue, which means this can't be blue, so that's blue. So red, 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 I believe. right? Red and red, and that's the last red. Then you'd have blue and blue, and this would be the last blue. So if this is red, then this would be red here, which means this can't be red, so this would be red here. So this is not either... we have blue in some sort or red in some sort. Okay. So one of these reds is going to have to add up to at least 10, which means one of these blues must add up to 20. Okay. What happens if you have blue and blue? That means one of them would have to add up to at least, well, it'd have to have a difference of 10 with that one. Okay. What's an interesting one? This doesn't give us much information if it's these two. So let's try this one. If this is blue, this can't be blue. So therefore this would be blue, this would not be blue, that's red, which would mean this is not red, that's blue. Red eliminates red here. So this is red, which means eliminates red here. Blue eliminates blue here. Blue and red cannot be in the same set. So this would be red here. No red here. Blue eliminates blue here, so this is blue. So this would have to be adding up to greater than 10 or greater. So this would be 20 or greater here. Okay. This would have to be less than a digit, so it would be 8 or less. This could be 20 and then another, yeah, that'd be fine. So normal digit in that case. Okay, This is interesting. So this must have a value greater than 10. This must have a value less than 9. At least. Sorry, at most. So that means the ones that add up to it must be at most 8. Yeah, I guess part of the question is, what are the combinations, right? How do the combinations go together? Oh wait, you can't have 1, 1, and 1. You can't have 9, 9, and 9. You can have, because every set has the digits 1 through 9 once each. So that means you would have 1, 2, and 3 at minimum. Interesting. And 7, 8, and 9 at maximum, which is 24. Interesting. Okay. So this would have to be 6 at least. So it'd be 1 through... No, can add up to... So it'd have to have 1 in one of these cells. This would have to be 7, 8, or 9 there. In the rest of the... Yeah, the boxes cannot... The rest of set red cannot have a 1. Okay. I mean, that's still feasible. So these three must add up to at least 10. Oh, this must add up to at least 20. Right? Because it's greater than that, it has to be not. Oh, I guess it could be 19 technically. Uh, mm, hmm. Interesting. Huh. Huh. Uh, this just has to be at least 10. Hmm. So one of these is going to have to be 20 something. Um, hmm. So this is at most a 5 here. And if that's the case, this adds up to at least 10. This would have to be 19 at least. So that means 5, and it would have to be 6 and 9 at minimum. 6 is the lowest, 6 and 8, sorry, at minimum. So this would have to be 6 through 8. This could not be a 1. If this was 1, then this would add up to 1, 8, 9, which is 18 at most. So this cannot be 1, which means 1 has to be here or here in that instance. Um, could be 2, 8, and 9. That is possible. Jeez, this is not that restrictive. Bulls, blah, 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 blah. Okay. Hmm. So I think that's okay so far, right? So this must be at least 10. So this must be at least 19. Since it's greater, and on top of that, it has to be 9 or more away from the other digits. This could still be like around 10 also. Could be less, could be slightly more. Could be can't so then it could be up to 15. Um hmm. Oh, that's actually interesting. So what each digit must be counted 3 times, right? Each digit must be counted 3 times. So that means you have the digits 1 through 9 counted. So it's 45 times 3, which is 135. The value of all the triple-headed beasts must add up to 130. It must add up to exactly 135. Okay. That's interesting, actually. That's making me very curious about So we know these two have to be greater than... have to be at least 10. These have to be at least 10. We still have quite a bit of runway, right? If you have... yeah, you have quite a bit of runway. Because you have only minimum of 10, right? So that gives you, if you have a minimum of 10 for every triple-headed beast, that's 90, right? Which gives us 45 value in leeway. But the problem is, yeah. One of them is going to have to be, one of the blues is going to have to be 20. Or, sorry, 19 at least. That doesn't help too much. Okay, wait, hold up. Each of these values is between two other unique digits. Okay. So at minimum, they are... it has to be 11, right? 11, and then the other one is at minimum 12. But it could be reverse, right? So this could be 11 and this is 12. In every individual one, this has to be greater than a single digit. If we had a 1 here, this could be 2, and this would be minimum of 11. Okay. This is slightly different because we don't have a 1 here. So this could be minimum of 10. Same here. This is minimum of 10. Hmm. One of these is going to have at least 19. The other one, I guess it has to have a maximum of 10. No. It's at least 6. So the other one has to have a maximum of 15, or sorry, minimum of 15. Hold up, okay. So, right, so in that case, this would be blank. This would have to be at least 10 away from 1, maybe. This would not be red, so it's red here, normal. This is not red, blue, normal. This has to be at least 11, because... well, I don't know, hard to say. No red. No red, no blue. No blue, so no red here. So this is at least 10 here. This is 6 at minimum up to 8. $19, 10, and 1 potentially could work. Oh, that's interesting. This would have to also be at least 15. Here. Huh. So what's the blue then? So this is 19 at minimum, 15, 15. At least 10. At least 10. Hmm. Okay, in this case, so you have at least 1 and 2 here. Okay, so say this was 1, right? So this is the minimum amounts we're trying to get. So this would be 110. That would force this to be 19 in value, and this is 10. So then this could be 10 also. And this would have to be at minimum 2. So this would have to be at least 11. This has to be a value at least, at most, at least 6. 15 to 15. Because it has to be at least 10 away from that. This we don't have a minimum or whatever. So since this is 1, this could be 2 and 1 here. Which could be 11 away from both. And same with this, 11 away from both. This would have to be 6 through 8, so minimum of 6. This would have to be a different set. So it can only share 1 digit. So this would be minimum of... one, 1, 4, 5, if this is 1, 2, 3. So this would be 10 at minimum. Okay, what does that add up to? So we have 11 plus 15 plus 10 plus 15 plus 11 plus 10 plus 6 plus 19 plus 11. That's still quite large. We have a large buffer that we could do. Huh. Interesting. Okay, not too helpful. And it goes the other way too, right? Hmm. Uh, hmm. That's not that restrictive. Oof. What happens if we go the other way? So if we go the other way, so not that. This is red, which means this can't be blue. Red eliminates red here. Blue eliminates blue here. So this is red, which means this can't be red. That's blue, which means this can't be blue. Red eliminates red here. So this is red, which eliminates red here. So that's red. These can't be in the same box and in the same column. This can't be same thing. So we have blue and blue. This again is normal, so this is at least 10 here, which makes this at least 19. And this could be 10. One, so that would force this to be at most 10. You could have 6 here, which gives you 15 and 15. These are interesting. 6 and 16, I guess, are the minimums. And then this could be 10 also. Hmm. So 11 plus 19 plus 6 plus 16 plus 10 plus 15 plus 15 plus 10 plus 11. Yeah, still we have 20, 22 in leeway here. Uh, uh, this definitely seems very hard. The concept of the rule set is very cool. The numbers, though, are very... There's not that much restrictions here. Problem is I don't know. I guess... I mean, we do have everything except for the middle rows and the middle columns. We don't know where the... We don't know where the triple-headed beast cells are there. Except for, well, the center cells we do, but we don't know which color is which, right? Huh. That's interesting. You're always sharing, so for if you have this combination, you're always sharing one digit. That means the difference between one set has to be at least 10 from the other set. But they are each going to be two distinct digits. That's interesting. Does that tell us very much? I don't really know. Hmm. um, the thing is, yeah, 24 could be in pretty much every place, right? So 20, there's no restrictions on the topmost digit or the topmost value, really. 24 can be in any of the places and it would fit the lines fine. Uh, Hmm. I need to go to the bathroom. I'll be right back. And I'm back. Actually, I'm gonna be taking a break because I'm feeling very tired right now. I woke up really early, couldn't get back to sleep, so basically decided to do some Sudokus. But I'm starting to feel pretty tired, and my brain isn't working very well. And these there are not enough restrictions here right now that I can't think of. So I'm going to be taking a small break. Um, Hopefully you get to see the second video in part two. Uh, I'll see you in that next video. Take care.